Hi everyone, I'm Amir Hussein. Welcome to this new training video. In this video, I will show you how you can verify or validate your WRF model output using the Landsat satellite image. So you know that we use the RTTOV model for simulating satellite image and then comparing the simulation, the RTTOV simulation with the satellite observation data. So in that case, you can get a good verification or validation of your WRF model output with the satellite observational data. Here we use the RTTOV Pi package. I have already discussed about this package. This package helps you to run the RTTOV model and compare your simulated RTTOV with the satellite image, with the satellite observational images. And after cloning this package in your local machine, let me open the name list and show you more details here. This name list, here we have some directives: RTTOV version, RTTOV installation path. I have already discussed about these directives in the previous videos, but let me show you about the coefficient file path directive. This must be related to the Landsat data and the satellite image data that you want to use to simulate its data. So let me show you what wavelengths are available inside or supported with this coefficient file, RTTOV coefficient file. You can run RTTOV Pi and with a additional flag wavelength and then the path to your coefficient file. Wavelength, and here it prints out all the supported wavelengths by this coefficient file. So you can see that here we have 9 channels, 9 available channels which can be simulated by RTTOV Pi. These 9 channels are supposed to be inside this Landsat 8 satellite data. So here let's get back to the name list, and in the name list here is the path to your WRF model output. RTTOV Pi has another capability, and it can print out the time range within the WRF model output. So here, if I run it as Python RTTOV Pi, let me print out the help WRF time. If I print it as WRF time, and now the path to the WRF file, it prints out the available time range, the available dates and time, and the time range within your WRF model output. And here you can see that your simulation, WRF simulation, starts at this time and ends at this time. So you can pick whichever time you want to simulate its satellite image in this range. But you should be careful that the time you pick in this range, there is available satellite image, satellite observational image for it. So you can compare your RTTOV simulation with the satellite image. So here I picked up this time 2022, month 5, day 16 and hour 12. You can see that this the simulation time is inside the time range of our WRF model. And also I have already downloaded the Landsat data. Let me show you Landsat data, Landsat. Where is our Landsat data? Here. The directory that I have put my Landsat data. I have already downloaded my Landsat data. Here there are 2 TIFF files, 3 TIFF files here, and some other auxiliary data which are in the text file and XML file. So this is actually for the verification section of the RTTOF-Pi software. Before post-processing and verification of your WRF output using RTTOF simulation, you need to simulate the Landsat data. Here you just pick a good name, a suitable or convenient name for your RTTOF input directory, RTTOF output data directory, and we skip this section here for simulating dust affected radiative transfer simulation. We just skip this section. And the satellite information. The satellite name index is 4. So what does number 4 mean here? If I go back to the RTTOF-Pi repository directory and into the WRF data directory, there is a satellite name file here, and number 4, you can see that number 4 is Landsat number 8. So we are going to simulate Landsat image using WRF model output. And the satellite channel list that I selected here is 5 and 6. I can change it to any number within the range of, I already showed you the range here. Open the file. Let me, what happened to this? Yeah. Wavelength, Python, RTTOF-Pi, wavelength. Any channel between 1 to 9 you can choose to simulate. So here we chose number 5 and 6 for the Landsat data, for simulating the Landsat data, Landsat image. And here the satellite channel names B5 and B6, they should be the exact name inside the satellite observational data. So inside the satellite observational data, the band name or channel name for the channels number 5 and 6 should be put here, should be set for this directive, B5 and B6. These cannot be random names. You can put random names, but when you want to verify it, you will face problems. If your purpose is just simulating satellite image, you can give them a random name. But in case that you want to verify it, these names should be the exact name in the satellite observational data. For user-defined position, we set them true, and this 38 and 45 is the position of the satellite. So we just we just chose a position that is almost in the middle of the WRF domain. You can also see that here. Let me show you the geographical extension of your WRF model outputs. You can display it by WRF domain. Here, WRF domain, and it's not, yeah. You can see that the latitude range is in this range, and the longitude range is in this range, and the domain middle point is these names, 32.8 and 42. So let me change it to the domain middle point, 32 or 33 and 42. 33 and 42. Historical TLE, I have enabled it to true, or maybe let it false. Set it false. I set it false. It's not much necessary to have a historical TLE, but for this case actually it's better to set it true. But I just want to show you how you can simulate it. It's better to register in this website, spacetrack.org, and get your username and password, and then you can use the historical TLE, which gives you more accurate TLE information of the satellite. But it may or may not be significant. That TLE accurate data may or may not be significant in your output RTTOV output simulations. But here I just skip it, and yeah, for post-processing is the next step. Just let me run it. RTTOV Pi. It's now running and extracting required atmospheric data which are needed to run RTTOV model. So if I open one of them, you can see that your extracted atmospheric data from WRF model output are here. Temperature profile, water vapor profile, and other extracted data are available here. Now you run the model, the RTTOV model, and yeah, you run it, and it takes some time. Just let me show you how it is running this RTTOV model. If I go to the root directory of RTTOV Pi in the WRF data directory, I open the name list. Here in the second directive, you should specify the directory or installation directory of your RTTOV model, which is recommended to be RTTOV version 14 or newer versions in the future. And here it's actually because inside this directory, your root installation directory, there are some standard subdirectories. You don't need to be worried about how RTTOF-Pi runs your RTTOF model. So just specifying the RTTOF installation directory and also specifying the coefficient file, the convenient or suitable coefficient file for your satellite image that you want to simulate. These are almost enough for your simulation. Also, in case of simulating radiative transfer affected by dust particles, you also need to specify another coefficient file for the aerosols. But in this case, the only information you need to know about your RTTOF is the installation directory and the coefficient file path or address. You can see that it's still running RTTOF. More than nearly 3,000 grid points have been simulated here, and you can see that it's running very fast, running the RTTOF model very fast for each grid points. And in this case, you have RTTOF outputs for each of your grid points, WRF model output grid points. I think it should be finished very soon at these moments. Yeah. As far as I remember, we have less than 4,000 grid points for this WRF model output. Yeah, it's finished. It's been finished. So 3,844 grid points. The RTTOF model has been run for these number of grid points. You can see your outputs here. If I show the output for one of them, you can see that the channels, the process channels, number 5 and 6, these number 5 and 6 are exactly the same numbers that you put in your name list. And calculated brightness temperature for these two numbers. Calculated brightness temperature is 0 because these two channels are actually thermal channels, are actually visible channels. So for visible channels, there is no brightness temperature. And this is reflectance and calculated radiances. These radiance simulation is very important because you can verify your model output by comparing your satellite data values with these calculated radiances. Other outputs are also important. You can use for whatever application you need, but for verifying your model outputs, radiance is important because your satellite observation radiance is available in your satellite observation, and you can compare your simulations with the radiances of your satellite data. Okay, let me open the name list, and let me go to the post-processing section. Here I set it true. Landsat post-processing, you can change it, but I won't change this. Just leave it to be Landsat underline post-processing. It's a good name. And image plot all bands, this directive, set it true because it converts all your outputs to net CDF data, as well as plots your outputs to some geographical images. Let me run it, RTTOF-Pi. go to the post-processing, Landsat post-processing, and here, yeah, radiance, you can see the radiance, some outputs, and yeah, for some outputs there is no, for let's say for brightness, temperature, as I mentioned, there is no value because these are the selected channels, are visible channels, so there is no brightness, temperature for them. And also you can see that there are net CDF data for each output. Let's say for radiance, you have its you also have its net CDF data, radiance. So radiance NC. So for B5 and B6, you also have its net CDF data. This can be very useful if you want to do further analysis. You can use this net CDF data. This net CDF data is used to compare your WRF, to verify your WRF model output with the satellite data. But you can also use it for further analysis and further verifications or a statistical analysis you like. And yeah, let me go to the next step, which is open the name list, and the next step would be verification. I enable it, and I'm not going to change these directive names, verification directive suffix. We can change it, but I just leave it. And satellite file path, satellite file groups. If the satellite file groups is enabled, which is enabled here, this satellite file path will be ignored. So the satellite file groups are enabled, and our satellite file directory is here. So our downloaded satellite images, which are a few Landsat images, are contained by this directory, are contained in this directory. We can see that there are a few satellite images which I have already downloaded. So RT-TOF-Pi actually reads these satellite images available in this directory and compare it with your RT-TOF simulations from the WRF model output atmospheric data. Satellite sensor, this is very important. Which sensor is this? So the sensor, you can specify your sensor with by checking out the exact sensor available in this YAML file. Satellite sensor I put here is the number is 47. Number 47 is, let me see, 47 Landsat 8 or 9. Okay, this is the correct satellite sensor. It should be a correct sensor, otherwise it will throw errors. And Taylor diagram name, you should set a name for this Taylor diagram file or image. And keep remapped satellite, this is a directive which can also be useful and beneficial, so make it enable. And why it can be beneficial? Because your satellite data will be well, actually for verification, your satellite data are remapped or regridded on your WRF domain. Then when it is regridded on your WRF domain, it's possible to compare two matrices with the same size. It's possible to compare two matrices, but here you can keep the satellite, the remapped or regridded satellite onto your WRF domain because you may like to do further analysis or a statistical analysis. Here, the only statistical analysis available with this RTTOF Pi software is Taylor diagram. You know, Taylor diagram provides you some standard statistical metrics such as RMSE or correlation, but you can also do more statistical analysis and more sophisticated statistical analysis. I save it and I changed the Python environment here because one Python library for drawing or plotting Taylor diagram is needed, which is required, is inside this new in this environment. So I needed to change the environment. I run it, Python RT12. These are some warnings. You can just skip it. It's okay. Verification processing on satellite Landsat band 5. Remapping satellite data on the WRF grid structure. You can see that it's remapping data because remapping is required for verifying your WRF model output. The first step is remapping your observational satellite data on your WRF model. And in that case, as I explained earlier, in that case, you have two matrices with the same size, which could be compared with each other. If you don't have two matrices with the same size, so comparing these two matrices would be challenging or maybe not possible. So the first band is completed. The first verification is completed here. Remapping satellite data on the WRF structure, and first verification is complete. And it's now working on the second verification. The second is also complete and storing extracted value in the next CDF file. The outputs are stored in a new directory, Kuwait out process. Verification, yeah, verification, Landsat verification. And yeah, this is the yeah, your Taylor diagram. This is your Taylor diagram, and this is the outputs, the value of your Taylor diagram. It may not be, it may showing high errors, but anyway, this is just a showcase of how you can run your WRF, or work with RTTOF Pi model, because there are some other issues. Let's say the closeness of your satellite data with the WRF model, and also you should be aware that the Landsat is a very small. The footprints of the Landsat satellite is very small comparing to the WRF model output, and maybe Landsat is not a perfect satellite data to be used for verifying WRF model outputs because it's very small. But you can solve that challenge by using multiple Landsat satellite data. But in this case, I just wanted to show you with how you could verify it. In a real test case, it's better to download many Landsat satellite data, let's say 10 or maybe more than 10 satellite data, Landsat satellite data. In that case, you will have a bigger area, and the bigger area would be more meaningful can give you a better result for verification. Also, you can here you can see the satellite, see the output, the remapping Landsat data on your WRF model output, and here you can clearly see that a small area of Landsat, you can clearly see the small area of Landsat with regard to the whole WRF model. So this is the reason that your Taylor diagram showed high errors. It's better to select much more Landsat images to cover the bigger area. But this was, as I explained, this was just a showcase of how to run ArchiTov Pi software and how to use ArchiTov model for verification, for simulation of satellite data and verifying your WRF model output.